In space, distances are often measured in light years. But what is a light year, exactly? Simply put, a light year is the distance covered by light in a single year. This is Mira. In this episode, we will wonder how the light year unit was created. What it tells us about the universe if we travel by the speed of light. And can we even ever travel at the speed of light? A light year is the distance that light travels in 1 year. In other words, it is a unit of measurement for distance, not a unit of time as some confuses it so. Light travels at a speed of about 300,000 kilometers per second, 186,000 miles per second, so a light year is about 9.46 trillion kilometers, 5.88 trillion miles. The light year is a relatively new unit of measurement. It was first used by astronomers in the early 1800s. Astronomers needed a way to measure very large distances in the sky. At that time, the largest distance measurement astronomers use is the astronomical unit, or the distance of Earth from the Sun. But even so, it is not enough to measure stellar distances, as it would still be too large of a distance. This is why light year was eventually used as a standard measurement. The light year unit first appeared a few years after the successful measurement of the distance to a star other than the Sun. In 1838, Friedrich Bessel used a 160 mm aliometer designed by Joseph von Fraunhofer to measure the distance to 61 Cygni. This was the largest unit for expressing distances across space at that time. The trigonometric calculations based on 61 Cygni's parallax of 0.314 arcseconds showed the distance to the star to be 660,000 astronomical units. Bessel added that light takes 10.3 years to traverse this distance. He recognized that his readers would enjoy the mental picture of the approximate transit time for light, but he refrained from using the light year as a unit. He may have resisted expressing distances in light years because it would reduce the accuracy of his parallax data due to multiplying with the parallax. What would happen if you traveled at the speed of light? If you could travel at the speed of light, you could go around the world 7.5 times in 1 second. You could also travel to the moon in less than 1 second, and to the sun in about 8 minutes. But what would really happen if you could travel at the speed of light? If you just circle around the globe, eventually, you would be traveling so fast that you would be able to see the back of your head. First, let's think about what light is. Light is a type of energy that travels through space and is used to see things. It is made up of tiny particles called photons. When light hits an object, it reflects off of the object and into our eyes. This is how we are able to see things. But what would happen if light could travel through an object? If you were able to travel at the speed of light, you would be able to pass through objects. This is because the photons that make up light would be able to pass through the atoms that make up the object. So, if you were traveling at the speed of light and came to a stop, you would be able to pass through the chair, the floor, and even the person sitting in the chair. But what would happen if you kept going? If you kept traveling at the speed of light, you would eventually reach the edge of the observable universe, but never the edge of the whole universe. This is because the universe is expanding, and the further you travel, the more space there is to travel. Einstein's theory of relativity is one of the most famous and well-known theories in physics. It's also one of the most complex and difficult to understand. In a nutshell, the theory says that the laws of physics are the same for all observers, regardless of their relative motion. So, what does that mean? Well, let's say you're sitting in a train that's moving at a constant speed. From your perspective, everything inside the train is moving at the same speed as you are. But from the perspective of someone who's standing on the platform, watching the train go by, everything inside the train appears to be moving slowly. The theory of relativity says that both perspectives are correct. The laws of physics are the same in both cases, even though the observers are in different states of motion. The theory of relativity has some strange and surprising consequences. For example, it predicts that time runs more slowly for objects in motion than for stationary objects. That's why a moving clock appears to run more slowly than a stationary clock. The theory also predicts that mass increases as an object moves faster. That's why it's harder to accelerate an object to high speeds. The faster it's going, the more massive it becomes. These and other predictions of the theory of relativity have been verified by experiments. The theory is now an accepted part of our understanding of the universe. Can we ever travel through space at the speed of light? This is a question that has been debated by scientists for many years. Some say that it is possible, while others believe that it is impossible. So, what is the answer? In order to travel at the speed of light, an object would need to have infinite mass and zero size. This is because the mass of an object increases as its velocity increases. So, an object traveling at the speed of light would have an infinite mass. However, there are some objects in the universe that do travel at the speed of light. These are called photons. Photons are particles of light. They have no mass and they travel at the speed of light. So, it is possible to travel through space at the speed of light, but only if you are a photon. What does this tell us about our ability to traverse the universe? Click our next video to know about the methods scientists are utilizing interstellar travel.